it. Look, you wrote the core becomes magnetized and it tracks the iron armature. This causes the pivot to move downwards and the two springy metals contact each other. When they contact each other, a complete circuit is formed and the motor switches on due to the flow of current. So core becomes magnetized due to the current in the coil. Iron armature attracted to core, contacts touch. Here, how many marks I gave? Huh?
3 marks, no?
3 marks, right? So you understand it, right? How to get 3 marks? You wrote core becomes magnetized, so it is okay. Uh, the iron armature attracted to core, so you wrote this causes the pivot to move downwards, and the two springy metals contact each other. Where is two springy metals? Where is springy metals? This one. You mean this? Okay, then it is coming the third points. Context touch, huh? So you got here 3 marks. 3 out of 3. Done. This one is 3. The next one, explain why the core is made from iron. Because it can be easily magnetized and demagnetized, it is also not able to keep its magnetism for a long amount of time. Iron is a soft magnetic metal which makes temporary magnet. With a steel core, motor stays or as contacts stay closed even if the switch S is open. So the discussion you made, it's okay. It is not. It is also not able to keep its magnetism for a long amount of time. Rather, you can bring the idea of steel. Huh? So it's much more specific. However, I am giving you here 2 marks. Then students suggest that a motor, because there is a chance of being electrocuted due to large amount of, okay, this one is okay, safer. So when you'll get the feedback, then you can compare your answer, right? And it's permanent in your email. This time I made the paper in a way so that you can have the feedback clearly. I gave it built in. When I will send you the email, then you will get the feedback automatically. So did you give here file or you gave an email?
What's this? This.
Yeah, this one. Look at the feedback. At least two lines near coil and horizontal near center and converting at least six wires, covering at least six wires of coil. Correct shape of lines fanning out at ends of coil. At least two lines passing outside of the coil from one end to the other. For correct direction of field lines at least on one line and none wrong. And pole on right hand side. So your north pole is right side, and correct direction. We have correct direction. Yeah. The magnetic field lines, when you are drawing, you should be careful. They should not touch each other. Hello, Tamjid. Tamjid,
जी सर हाँ sir.
this magnetic field lines should not cross each other.
Hmm.
Be careful.
Okay.
You you did not show the lines inside. That one should be shown, and in the center it should be horizontal. These lines.
Hmm. अच्छा.
Look, I am showing you the points. At least two lines near coil and horizontal near center, and covering at least six wires of coil. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our line should go through here, at least six wires covered. Then correct shape of lines pairing out at ends of coil. Your shape is okay, only one thing is problem intersecting, and you should continue inside it. At least till this wire you continue. It's like you have shown that it's discontinued from here. It should be continuous line. When you are drawing, it should be continuous line. Is it clear? Tamjid? Tamjid, keep your microphone on. Yeah? Tamjid? Hey, Tamjid. Tamjid. This way, Tamjid. Oh, disconnected completely. Okay, look here. The line should be continuous, eh?
Hmm.
And this way will continue horizontally, eh? And
Hmm.
we do not need so many lines, eh? Only you give here three, eh? Here you give 3 lines, and here you give 3 lines, 6 lines enough, eh?
Okay.
Okay, and the most important thing is here you are intersecting lines. This is very dangerous. Never do it, eh?
Acha.
Okay, so here you are getting you look, this point is okay. The first point, you missed the first part, that is showing horizontal near center. You did not show this part. Yeah, number 2, correct shape of lines. This is fine. Number 3, at least 2 lines passing outside of the coil from one end of the other, one end to the other. At least 2 lines passing outside of the coil from one end to the other. So this is also okay. This one I accept. That correct direction. This is also okay. And pull on the right side. Now here I want to cut one mark only. So out of 5, you are getting 4. Huh? Try to make your drawing more better. Huh? Especially that one, the lines intersecting each other. That is really dangerous. That is not correct. Now here we have describe how a permanent magnet is used to produce a large reading on the ammeter. The speed at which the magnet is plunged into or withdrawn from the magnet must be very fast. Move magnet into the coil or move magnet quickly or
Sir,
move
1 minute. Sir,
stronger.
1 minute break.
Okay, okay. Amjid, are you listening?
Yes, sir. Huh.
Okay, keep your microphone on. So I explained that one. Did you understand that in mark
হ্যাঁ
scheme,
হ্যাঁ
the way
হ্যাঁ
it's
স্ট্রং
written,
ম্যাগনেট ইউজ করতে হবে
yeah, you for writing only this part you are getting 2 marks. One is for withdrawing from magnet. This is 1 mark. Another is mentioning very fast. That is another mark. So I gave you 2 marks, but we have 2 ways. We have 2 ways to get this one. One is they are saying larger reading, right? One is move towards or away from the coil, move magnet towards or away from the coil quickly and use stronger magnet. Is it clear now?
হ্যাঁ স্যার
So you got your 2 marks. At first I thought that for writing both of them you have 2 marks, but now I checked, then in mark scheme only for writing this part is 2 marks. Okay, now look, explain why current is produced in C1 lines, because magnetic field change occurs. This causes EMF to be induced in the circuit, hence okay, it's fine. Flux in coil changes. Magnetic, you can also write lines of magnetic field cut the coil. Okay, this one also you can write. So here you got 2 marks. So look here, they did not ask you about this Fleming's left hand rule here. The this causes to look what they are asking in the question. What will be the current direction in the circuit? What will be the current direction in the circuit? This is the question. Okay.
Oh, okay.
So the current direction is from positive to negative. Eh?
Mm-hmm.
Explain why the copper wire moves along the copper rods. So here you got it. Fleming's left hand rule, you can use it here. Because force is acting only on the copper wire but not on the rods. Current and magnetic field create a force. Fleming's left hand rule is used. So I am accepting your previous one. You mentioned Fleming's left hand rule. And current and magnetic field create a force. That one is also there, right? Your thumb is showing force, isn't it?
Hmm. Hmm.
So why the copper wire moves along the copper rods?
Because force is produced due to current and magnet, and Fleming left hand rule is okay. Hmm.
So
Okay, sir. What's
what you said here, because force is acting only on the copper wire but not on the rods.
ওই অ্যান্সারটা নিজে হওয়া উচিত ছিল।
Yeah. So here this is actually not necessary to mention that which one is moving, which one is not moving. They did not ask you that. They only asked you that why copper wire moves. You just tell it why it's moving. So you mention it clearly because current and magnetic field create a force. Huh? I'm giving you 1 mark. Electric motor, DC motor, and moving coil loudspeaker. Yeah, yeah, very good. So you got your 2 marks. Why you are saying coil A has larger number of turns? Okay, yeah. You say what is the question asking? State whether coil A or coil B has larger in the transformer has larger number. So this one is step up or step down transformer.
Step up.
How is step up? Is
স্যার এটা উপরে না?
from grid line to house, not power station to grid line.
Oh, okay.
Your house is getting low voltage than the grid lines, isn't it?
Hmm.
So it should be step down, right?
Hmm. Okay, okay. Hmm.
Oh, so this one was a very easy question.
স্যার আবার একটু এটা এক্সপ্লেন করবেন?
Yeah, look here. If we have, you can check your notes. If it is from power station, if here we have power station, huh? Then we are having step up, huh? From here to here. This is power station. Then it is step up transformer. We need more voltage in grid lines.
Hmm.
So then after grid lines, you are going to house again less voltage. Before grid line in the power station, low voltage. In the grid lines, we have always maximum voltage. Is it clear?
Hmm.
So from grid line to our house, it is step down.
Hmm.
Is it clear now?
Yes, sir.
So here you got 0, then
Sir,
3V.
number of turns and voltage ki directly proportional.
Yes, yes. Vp by Vs equals Np by Ns.
Hmm.
Is it clear now?
Yes, sir.
Your this one can easily be magnetized and demagnetized. It is fine. This is one of the properties of iron. But what is appropriate for transformer? That is this one. Okay, so
Hmm.
you write this one to transfer the field from primary to secondary or to increase the field in coil B. Okay.
अच्छा एक मिनट लिखे नहीं
No, I will give it. The feedback will be there. It will go. When I
ओके
send the email, it will be going there. I am accepting your answer. Can be easily magnetized and demagnetized. It is also one of the reasons, but this one is more appropriate. Okay.
हम्म
This time I made the script in a way that the feedback will go automatically to you if I send the email. Okay. Your answer and my feedback will go automatically. Describe briefly how an output voltage is used in coil B. It is used in proper operation of electric with the changing magnetic field or field lines cut. They are actually asking about the coil B here specifically, okay, not any other example. They did not ask you other example or other appliances how they are working. They are asking specifically for here this transformer. Yeah, you can see the feedback. I gave details, all the advantages
हम्म
and disadvantages from mark scheme I gave. So, Tamjid,
जी सर
can you favor, may I have 10 minutes break?
ओके नो प्रॉब्लम
10 minutes break, then I'll come back.